Hello Science 30s. In this video we're going to be looking at Watt's law and some other of the and some more electricity formulas that you need to know for Science 30. So if we go and take a look, it's in your data booklet, at the different electricity formulas. So what we have here is we have the one we've already talked about right here, which is Ohm's law. So here's Ohm's law. And then here is Watt's law right there. This is Watt's law. And then we'll also see this this formula in action today as well. And so let's get right to the examples. Okay, so here is the first example. We'll do them one at a time on this one. And so using a simplified approach, a speaker can be treated as a device that offers 4.0 ohms of resistance. R is equal to 4.0 ohms to the AC input signal, allowing only 2 amps, 2.00 amps of current to flow. Calculate the power consumed by the speaker. Okay, so we have two variables given to us, and we need the third one. So let's go take a look at which formula we would need. We have P, we have R, we have I, and we need P. So we go up to here, and there's only one formula that uses P, I, and R, and we're going to come back to that one. The way we're going to do this one is we're going to use two steps. The first step, well, first of all, I noticed that P is also equal to IV. That is Watt's law. And we don't have V in this case, but we can figure out V by using Ohm's law. And so that's what we're going to do. We're going to do a two-step process for this first one. So we also need, in this case, we also need V. V we don't know, but we know that V is equal to IR, which we are given. And so we know that's going to be 2.00 amps multiplied by 4.0 ohms. And an amp ohm is equal to a volt. And so that is going to equal 8.0 volts. Now that we have the volts, we still haven't actually answered the question, because the question says calculate the power. So what we're going to do now is we're going to use P is equal to VI or IV. It doesn't really matter which way you go there, in order to solve this. And so this is going to equal 8.0 volts multiplied by the current, which is 2.00 amps. And we obviously are going to get 16 watts on this one. And there's my final answer. So we're going to get into a little bit of algebra now onto how we would combine these two formulas. So what I mean by combine these two formulas, we have two formulas here. P is equal to IV or VI, it doesn't really matter like I said, and we have V is equal to IR. So what I'm going to do here is I'm going to say, okay, well, what if I didn't have V? Do I have to do two steps? And no, I don't, because if you notice here, we have P is equal to IV. Well, there's V and there's V. V is equal to IR. So what I'm going to do is I'm going to take this IR and I'm just going to put it right in the spot of that V right there. And then so P would equal I, and then in brackets, IR. Well, using distributive property from mathematics, we then will say, okay, I times I is I squared R. And there we are. And that's going to be our new formula, which is the formula that we haven't gone over yet or seen an example of. So what we're going to do is we're going to look at another example now then, up here. So you see over here in this question, we had given to us, we had ohms R and amps I. So we had I and R given to us, and we figured out P by going through a two-step process. Over here, we have the exact same things given to us, different numbers. We have ohms and we have amps. So my resistance is going to equal 4.0 ohms, and my current is going to equal 4.50 amps. And once again, we are calculating the power. P is equal to that question mark. But now instead of figuring out V first and then plugging that into the other formula, we're going to go ahead and just do that one formula. So we're going to say P is equal to I squared R, which is equal to 4.50 amps squared multiplied by 4.0 ohms. And we get a final answer here of 81 watts. And that's how you use those two formulas.